Thank you, everyone. Hope you are enjoying the first Data Saturday. This is very, interesting time for us because since the past ceased operation, community has been coming together to continue the training and the support, for the data platform community. And I also want to thank the organizers for arranging this and giving me the opportunity. So today we'll be talking about intelligent query processing in SQL Server, and this is applicable for both on-premise SQL Server, Azure SQL Database, SQL Server on VM, SQL Server on managed instance, and I will, clear up if there are features that are not supported in any particular version. I'm not going to talk about my bio. I just want you to take a note of my contact on the left side of this slide. In case if you want to ask me a question later on, follow up or any comment, you can contact me using any of these ways. I do monitor all this, so LinkedIn, Twitter, direct email, anything will work. So why we want to talk about this, right? What is the problem, or why do Microsoft came up with these features, right? First, if we do not appreciate that a little bit, the talk will probably not make much sense. So whenever we submit a query to SQL Server to get a set of results, first the query has to get compiled to an execution plan. And once we get execution plan, and then only you can get the result. Now, we're looking for a good enough execution plan, and with a lower compile time and the optimal amount of execution time, right? We are not looking for the best execution plan. So during query optimization phase, there are a couple of things that happen, and I'm not going to talk about this in detail because this itself can be a talk. So during the parsing phase, the SQL Server, it creates a logical tree, and then it goes to the transformation phase. And it doesn't just create one logical tree, it creates a bunch of those because there are different ways you can get a query to execute. And then it goes to a transformation phase. It looks at different variation of the tree, and then looking at the estimated number of rows for each operator get a cost, and all those costs get added, and based on the total cost, it looks at which one has the minimum cost, and that one gets selected to get executed. And before that, there's a compare cost, and the one that gets selected, it gets put into the cache. And why does SQL Server do that? So next time, if you submit the same query, it creates a hash and compare the hash and see, hey, did someone call this query before? Is it the same hash? Yes. Then I do not have to go through this first phase. I can directly take that query from the query plan from the cache, and I go to the phase, the last phase that you see in this slide is a query execution. Now, during this execution, or during these 6 phases, if the cardinality estimation go wrong, and I'll talk briefly what happens or why it can go wrong, right? Our costs will be wrongly estimated, and the plan that gets into the cache is probably not the optimal plan, or not the plan that we wanted this query to be executed. And because of that, our concurrency will reduce. We can process less queries now for a fixed amount of time, and our throughput get affected. To give you a quick example, like a memory grant, right? If my query need a sort operation or a hash operation, I need certain amount of memory to get this done in the memory. Now, if my estimates are wrong, I can either get less memory than I need, or I can get more memory. Both are bad, and we'll talk about a little bit. Now, why, if you see that, on my here, I put a big wrong cardinality estimation, right? Why can this go wrong? There are a couple of examples or a couple of points that I can talk about, and this is not the whole list, right? We can have a missing statistics. We can have a stale statistics, means, we updated the statistics, then there are a bunch of rows got insert, updated, and deleted. We might not have a adequate sample, right? Because if you have a huge table with billions of rows, it is not practical for you to go and create statistics with 100% sample. So oftentimes we do create it with a sample, and that might not be adequate. Parameter sniffing can be a reason. And there are out of model queries that we'll talk about, and that's one of the main reasons that Microsoft came with intelligent query processing, like table valued function, table variables, X queries. These are some of the constructs that if we use within our T Sql SQL Server cannot correctly estimate how many rows might get qualified. So let's talk about a little bit more detail what happens when these estimates go wrong. And this is not, again, a full list. I'm just trying to give you a couple of examples. As I said, that based on the cost of my operator, this bunch of decisions get made, right? Should my query go parallel, or should it execute in serial fashion? So if my estimates are low, even though I could have gone parallel, now I cannot go anymore, right? I'm now executing this query in a serial fashion, means I cannot take advantage of parallel execution and do it quickly, and vice versa. If the estimates are high, now I'm going parallel, whereas I didn't need to go parallel. I could just execute serial and save some of the schedulers or some of the CPUs for other queries. I briefly touched about memory grant, right? So again, spill to disk, right? If I don't have enough memory, I have to do a big sort. Because my estimates were wrong or estimates are low, I got a small number of memory than I needed to. Now I'm going to spill to 10 dB, so I have to write there. I have to sort it, I have to bring it back. So it's again a slow query, right? And my throughput is going to get affected. Access method, SQL Server, whenever it needs a set of data, it can do either a seek, it can do a scan, or it can do a combination of seek plus scan. And how does SQL Server decide that? Based on my cardinality estimate. Algorithms, right? What type of algorithm I do use, right? For joins, there are 3 different type of physical algorithm: nested loop join, hash join, merge join. We'll also look at a brand new one today called adaptive join. For aggregates, we can do stream aggregate, we can do hash aggregate. For sort, we can do it in memory, or we can do it in TempDB. So all of these things that you are seeing on this screen, this is just a subset that can get affected based on my cardinality estimate. So why did I say that, right? And I'll come to the reasons that why Microsoft picked these items and try to solve some of the problems that I just explained to you. So with the release of SQL Server 2017, Microsoft really did not call this intelligent query processing. It used to be called adaptive query processing. And the one you see that I circled with the orange square, those are the features that were released with the SQL Server 2017. And then the one now you see with the green color or greenish color, those were released in 2019. And the whole set is now called the family of intelligent query processing. And this is going to expand, and I'll talk about that a little bit, what's in the pipeline for 2021, because Joe Sack and Pedro Lopez from this team at Microsoft talked about it during the past summit last year. So I'll touch that a little bit. So at the beginning, I said that these are all available for many flavors of SQL Server, but I want to make a note here that you see that Scalar Udf Inlining, that's on the top line from the left, the fourth one, that is not available with Azure SQL Database in Azure at all. And the one you see that approximate count distance, that's to the far right, this is not dependent on compatibility level. And I'll talk about compatibility level a little bit more. Some of the stuff you see that it only available for batch mode, right? There is one called adaptive joins on the left. You see that it's only available for batch mode, but there is another feature called that the row store also should be able to take advantage of batch mode, which is a new feature. So if your row store is getting advantage of batch mode, then it can also take advantage of the features that qualifies for batch mode. I know, if there's any confusion, please put your questions in the chat, and the moderator can stop me and I should be able to answer the question. You do not have to wait for the end. Just put your questions anytime you have one, and I'll stop there and I'll try to explain it a little bit more. So what was the thought process for Microsoft engineers to tackle these points? One of the thing that the code refactor take times, right? It's easy for us, like for me being operational DBA, to tell someone go and rewrite your function, don't use a function. It's easy to tell, as you know, if it's a complex piece of code, it's not that easy to implement, right? Even though you write it, it has to go through different phase of test and all that. Other issue that Microsoft is trying to tackle now, before, as I said, once a query was compiled or a query plan, it get put into the cache and that's it. Till that plan get evicted for many reasons, you keep using it. Even though it knows that, hey, I did not grant enough memory, or my estimate for this table variable is not accurate, on the second execution or third execution, there was no attempt to fix this. So finally, Microsoft said, hey, I already know that I had a low memory grant or had a high memory grant. Why not try to fix it on the fly during the next execution? And there was some old limitation, like with the Scalar Udf, and some of those that Microsoft didn't tackle before. Now they're trying to do that. So 3 basic principles. These features, you do not have to do anything to take advantage. These are controlled by your major version of SQL Server and also by your compatibility level. So as soon as you upgrade and you are using default compatibility level, or you have a chance to switch compatibility level, like why I say that, right? A chance to switch compatibility level. Once you are using Azure SQL Database, there is no concept of SQL Server 2016, 17, or 19. The only way you can control behavior is via compatibility level. And I'm not going to talk about that in details, but if you're not aware of compatibility level, I will highly urge you to go and look at it, because even Microsoft now pushing the vendors to certify their product based on the compatibility level, not on the SQL Server version any longer. So once you have the right compatibility level, the feature is turned on automatically. You do not have to do any code change. You do not have to do anything. So that's one of the principles. Other principle that Microsoft is trying to follow is improve the performance of the existing workload, right? So your existing workload should not digress, should not go, in the wrong direction. And critical, parallel workload when running at a scale will also remain adaptive. So there shouldn't be any change when you scale out or you scale up. So these are a couple of principles that that's behind these features. So before I dive into this, I just want to talk about a little bit, and I know past ceased, but at some point, I hope this year, some of the sessions from the past 2020 recordings will show up. I don't know where it will show up. There is a whole session was done called Azure SQL Path to an Intelligent Database. So try to look at that. I'm not going to talk about this because I cannot demo this right now. But it will come out in 2021, and this is not an NDA for MVPs or anything. This was talked publicly during past Summit 2020. So one of the things they will do is, or they're working on, Microsoft engineers, is if you see a query in query store, it can be a vendor application. You might not have the luxury to go and edit the code. You should be able to get the query ID from the query store, and you should be able to add a hint based on the query ID, because you do not have access to the query or you do not want to rewrite or change the code, you can just put a hint based on the query ID. So as long as that query reside in the query store, and that query hint is going to work. So that's one thing they're working in 2021. Other one is pretty much, it's going to give you give feedback. So whenever they see, a piece of code is not running optimally, it will look at that, it will look at the cardinality estimate, and it will give feedback. Hey, there are a couple of examples that I put here, to fix it on the next execution. Now on this, if you have hard-coded hints, but it really think that you should put a different hint, your hard-coded hints will get a preference. Again, I'm not going to demo this. I just put this for you as as an FYI that these are coming in the pipeline. This is a DMV. So I said, as soon as you have the right cardinality estimation, as soon as you have the right compatibility level, these features are automatically turned on, right? Now you might want to not enable it for the whole instance, right? You might want to disable it at a database scope or control it. So there are 23 different settings. If you go and look at this system catalog view, as of SQL Server 2019 CU9, there are 23 of those. You should be able to go and use these hints to control this at a database level. You can also go one step down and control this at a query level. So these are, again, there are 23 of these into this DMV that you can use with the use hint statement. So say you have this turned on at an instance level, of course, then it's turned on at a database level, but you do not want to use this for this particular query. You should be able to use one of these hints, and I have examples at the end how to use those hints. So going forward, all my slides, you will see these three signs at the corner. So if I put the simple symbols just to keep me on track, also for you to make it easy that what this slide is talking about. So like this is a problem slide. What I'm trying to say is what problem Microsoft is trying to solve. So the first one out of those 7 is called adaptive join in batch mode. And as you see on the left side, I did not put a major SQL Server version, right? I put these numbers 140 and 150. These are default compatibility level for SQL Server 2017 and 19. Now, why did I put that, right? Because as more and more versions of SQL Server will be released and more and more features will be released, only way I can control this is by compatibility level. So today, just to give you an example, if I have a SQL Server 2017, which is by default, the compatibility level is 140. If I change it back to 130, means I'm behaving like 2016, adaptive join in batch mode will automatically, not work in my database, right? So I cannot take advantage of it. So I just wanted you to know that. So you might be upgrading a database from SQL 2012 to 2017 or 19, but it still stay in the old compatible level, then you wouldn't see that. So everything is controlled by the compatibility level, not by the version of your SQL Server. So what problem Microsoft is trying to solve with this, right? Joint hint. So as I said, there are 3 different types of joins: hash join, nested loop join, merge join. Oftentimes people will put hint into their query to use a particular type of joins, right? And the drawback is, your data set might change, and going forward, this might not be the optimal join anymore. Plus now you are really, overriding the SQL Server engine and the intelligence that built in. The other one is a parameter sensitive query. So how did Microsoft solve this, right? So now dynamically Microsoft is going to look at how many rows are being qualified for this join. And based on that, I put a URL there. You can go and read that. There will be a threshold. So if you're above that threshold, you still, by default, is going to do a hash join. So you still stay in the hash join. But if you drop below the threshold, then it will switch from a hash join to a nested loop join, and we'll see all of this in a demo. So I'll make sure I stop talking within the half an hour, so we have full half hour to demo all these 7 features. Also, I have this symbol, as you can see on the corner with the warning, means I want to, all of these have some caveats and some of the limitations. I want to make sure that I spell those out so you know. So this feature today is only available for select statements, right? And of course, because it's adaptive between hash join and a nested loop join, the join has to be qualified for both. And today this is only for batch mode. So what does that mean? Means either it has to be a column store index, or your row store has to qualify for a batch mode. So only then you can take advantage of this. And of course, the both joins needs to have the same outer reference. And if some of this doesn't make 100% sense right now, once we go to the demo, hopefully, it will be clearer for you. Table variable deferred compilation. So if you're working with SQL Server for a while, I'm pretty sure you know the problem with the table variables, because when at the compilation phase, SQL Server engine or the query optimizer doesn't have any idea how many rows are into the table variable. So what does it do? It just guesses that you have 1 row. And that's always a problem, right? And table variables, they don't have auto stats, like, they have no statistics. So, and you can declare indexes only when you are creating the table variable. You cannot say, I'm create this table variable, and later on I cannot declare another index. So these are some of the limitations of the table variable. So how did Microsoft solve this one? If during the compilation phase, it come across a table variable, it will put a pause. It will see how many rows are there into the table variable, and then it will do another, do some adjustment, right? Looking at the exact number of rows into the table variable, SQL Server will adjust your query plan. In that way, now you just get a better plan, because now you have a better estimation of the rows. Again, this does not change any other characteristics of the table variable. Does not, you do not get auto stats or anything else. And this does not also fix. Oh, I have a typo here. I don't know why it says parameter. I wanted to mean parameter sniffing issues. I'll fix that before I upload the slides. Why it doesn't do that? Because once it sees a table variable, it look inside and it knows how many rows are there, adjust the query, but then that get saved into the cache. Now, even though next time you call it with a different variable value, it's not going to do that again. That one is a fix. The next time doesn't matter what you call with, it will only use that plan. So if if you call with a different variable value that widely differ from your first call, it's not going to go and redo this thing. So till that query plan is evicted from the cache, you are kind of stuck there. Interleaved execution of multi-statement table valid function. So table valid function has pretty much the same problem that we talked about, the table variable. This used to get an estimate of 1 up to SQL Server 2012. In SQL Server 2014, things improved a little bit. Now the estimation is a fixed, it's 100. So again, same problem, right? So what it is going to do, again, during the compilation phase, if it comes and see that there is a, or during the, if it sees a multi-statement table valid function, it will put a pause, right? It will get a exact count or a true count of the rows that get qualified by that multi-statement table valid function, and then it will adjust the remaining branch of the execution plan. So you might not see this one will vary, right? Whether you'll see an improvement or you will not see improvement, right? Because it will already estimate 100. Now, if there is a small difference between the actual number of rows and that 100, you might not see a bigger impact. There are also a couple of restriction with this, like what will qualify. So your table value function has to be read-only and not part of a data modification, and it has to be a runtime constant. I put a URL there. If you do not know what's a runtime constant for a function, please go and read. We just do not have time to go through that here. Memory grant feedback. So I alluded to this few times, in previous slides. So and we know what problems can happen if you do not have the correct memory grant, right? So I'm going to skip this one and let's talk about how did Microsoft solve this. So once I execute a query, it's going to go and look at the current memory grant and see if there was a spill or the memory that got used and the memory grant, it look at the size, right? So if it sees that the granted memory is more than twice the size of memory that got used during the query execution, then it will trigger and say, hey, either I gave you more or less memory, so let's make adjustment. Also in the SQL Server Management Studio now, there is a new property that you can go and see if your memory is getting adjusted during the next execution or not. So unless you qualify those, unless there is a spill or you used twice, your grant is the bigger than twice the size of the memory got used, this will not trigger. Memory grants under 1 megabyte will not trigger. And if you use resource governor and you have set up memory grants that's different or it has a limitation, but the feedback is trying to give you more memory, your resource governor will still be honored. Memory grant feedback also was implemented for row store. It was only for batch mode in 2017. In 2019, it also qualifies for row mode. So it's the same things. I'm not going to talk about that. T Sql Scalar Udf Inlining. So why T Sql Sql functions, user-defined functions is a problem? I put a bunch of reason here, and I'm just going to go very briefly with those. User-defined functions are invoked in iterative manner, so it's a row by row, right? For every qualified row, the function get called once. It also has a lack of costing. So during the optimization phase, it really cannot estimate the cost of this function because it's a scalar function. So when at the beginning of evolve when SQL Server Engine was getting the new versions or when it came into existence, for scalar operators, they really thought it's going to be a small thing, so just use a little bit CPU. They did not had any algorithm to calculate the cost. But later on, when this came out and data sets get bigger and bigger, now people use these functions like a large data set. So that was a problem. If you have a T Sql Scalar UDF function, your query plan cannot go parallel. Another problem. And there are a couple of other reasons that I put that makes it slow. Now, how does Microsoft solve this? And again, there's a lot of restrictions today. Not all functions can take advantage of it. You have to read books online. So they will look at the, take the definition of your function and inline it so it doesn't go, and get rid of some of the restrictions that we saw in the previous slide. And once it get in line, there further optimization is going to happen. So this is, again, based on this Freud framework. I put a URL if you are interested. And of course, then, now you get set-based execution. And also in the management studio, there is another new property that I'll show you during the demo time. Again, I put a bunch of URLs here. You go and look at the requirements to be eligible for inlining. There were some issues in 2019. I think this got fixed in CU4 or 5. sys.sql modules is the first one to look at if you qualify for inlining. But even though you qualify, it doesn't guarantee that you will get inline. But if you're writing a function today and you say, hey, I really do not want the optimizer to make this inlining, right? So you can use the hints that I talked about before in your T Sql. But even within the function, you can put this inline equals off in your function definition, so that will never get inline in case for some reason, if you decide to. Batch mode on row store. So batch mode was introduced with column store index came out. But since then, the community has been asking for batch mode to be implemented for row store because column store index, it's not for everybody. It also has restrictions in certain places, like if you have trigger, cursor, persisted computed columns, you cannot do column store index. And the advantage of batch mode is instead of row by row, it takes approximately, there is a wide range of numbers, but approximately up to 900 rows can be processed at one time. So it's pretty fast, but mostly for bigger data sets. So now, even though you're not using column store index, you're using traditional row store index like the B-tree index, you can still take advantage of, of batch mode. Again, use heuristics. I'm not going to read this. One thing you have to understand that this will only help if your work is CPU bound, not IO bound. So I just want to make this clear. If your IO bound workload, column store index will help it, but with this, it's not going to. It will help you with your CPU workload. So again, there will be restrictions, as I said, like if you have a large object column, XML column, you will not be able to take advantage of this. Not applicable for in-memory OLTP. And again, these two features are totally independent. So column store index and batch mode, I know they came out together, but again, because now row store supports this, you just have to think this as two independent features. Approximate distinct count, as I said before, this is implemented in 2019, not controlled by compatibility level. Again, as you see the word approximate, so just be mindful. This is not for your financial, applications probably. This is more for you have, huge data sets. People are looking at trends. People are, trying to forecast what's going to happen in the future. They really do not need the exact count of data, right? Approximate count will help them. You can take advantage of this. Like I have example, like, dashboard scenarios, data scientists trying to understand data distribution. The memory footprint between the count distinct and approximate distinct count is a mind-blowing, and we'll look at that, during the demo. It's based on this algorithm called hyperlog. If you're interested, go and take a look. Microsoft guarantees that with the approximate distinct count, your data set will be within the 2% error margin with 97% probability. These are some of the T Sql example. I'm not going to read this, how you can disable some of these features at a database level or at a query level if you choose to. These are some of the resources if you want to read more. And then I'm going to switch to demo from here. So is there any question at this time? This will probably be a good, good point or good timing if someone has any question before I go to the demo. Okay, I'm just going to keep going. I'm not going to run this script. I already ran it before I started this session. As you can see in my comment, I said it's going to take about 18 minutes. So this is pretty much a wide world importers data warehouse I downloaded, and then I have I put enough comments here. You should be able to run this. So before you go through If you want to run all the other queries or the examples, please run this before. Okay, so let's go. The first one we're going to talk about adaptive join in a batch mode, right? And I also put a URL, so I did not write these queries from scratch. These are actually from a GitHub of a Microsoft repo. From their intelligent query processing, I did modify some of this, and I put enough note. You can also send your comments, questions either to me, but if you want to directly talk to the engineers about any of this, if you have any questions or comments or any suggestions, you can send it to this email address. And Pedro Lopez, Joe Sack, they do appreciate all the community feedback because they are still working on other features. All of this, you will see that I will start with this. It's pretty much similar code. And again, I'm clearing the database cache, but please, this is just for demo purpose. Do not do this, take this code and start running in production, and it has, other implications. I'll change compatibility level in most of the scripts just to make the server behave, in a different way, so I can show these things to you. So like here, because I'm doing this demo on a 2019 CU9. But I want this to act like a 2017 because this feature came out in 2017. So I wanted you to make sure that, that I show you with the version that it came out. I'm going to turn on execution plan. There are two different kinds. One is actual, one is estimate. The difference is the actual one has the runtime stat. So I can turn this on from here, or I can also press Control M as I put it here. So if you don't want to, use your mouse, if you're heavy on keyboard, use Control M. So this is a simple selected statement, right? And if we run this and you look at this, so if you are on a compatibility level before 2017, you don't see this. Now you see there's a new join type called adaptive join. And if you see here, there's two branches, right? This is your outer table or the rows coming in. Now you have two here. One is, and if you see here, this one has 672 rows, but this one did not do anything, right? And if we hover on this, sorry. Oh gosh, what's going on? Okay. Now let me take this out. I wanted to do on this one. As you can see, it says physical operation, adaptive join, and actual join type is a hash match. Also look at this threshold that I talked about. So the threshold was 68, and the estimated number of rows was 206. Because it was above the threshold, it did a hash join. So now I'm going to delete all the rows for one of the quantity just to make a demo. Now I'm calling the same query. If you see that here, I called it with 360. Now I'm going to call it with 361. And this time, look at the join type. And we did not do any recompile or anything, right? So on the fly now, SQL Server can see that, hey, this time my threshold is 11 and I only have 10. So I'm below the threshold. I'm just going to do a nested loop join. So please, if you have any question, put in the chat to stop me if it's not clear or I'm going too fast. Now, as I said that if your row stores qualify for batch mode, you can take advantage. So we'll look at this because on the previous one, those are column store indexes. And this is a row store. And how do we know that it's a row store? Look at this. This is a row store, but we did qualify for a batch mode, and that's why this one did adaptive join here. If this did not qualify for a batch mode, we wouldn't see this here. Are you guaranteed to get an adaptive join every time? No, it is not. And that's why I said that it doesn't fix parameter sniffing, because it all depend on what your first, what plan is in the cache. So I'm creating a very simple store procedure here, just for demo purpose. And I'm calling this same one, first with the 10 and then with the 361. So you do not have adaptive join, right? Because the first one did not, it's a row store, and we did not get a batch mode, right? So it did not qualify. Now, if I evict that plan, this is a nicer way to evict a plan. It's just going to evict that one plan from the cache, nothing else. Now I'm calling this same one. Look at this. This is a 361 and this is 10. I'm just reversing the order. And now as you see that the first one qualifies for adaptive join, so automatically your second one will qualify for adaptive join. So sometimes it depends, what plan you have in the cache, how it was called on the first time. So the next one we're going to talk about is a deferred compilation, right? So I'm creating a table variable, inserting few rows, and then doing a select using that table variable right here. And I first want to show you the problem, and then we'll change the computability level and see, the difference between the two execution. Hopefully I turned on I did not. Shouldn't have done that. So sorry about that. I still didn't do that. So this one we are doing with 140 computability level, means 2016. Sorry, 2017. This came out in 2019. So look at this sort warning here, right? What is this about? This is telling us that we did not have enough memory. 6,634 pages spilled to TempDB. Now, why we did not have enough memory? If we go and look at this, look at the estimated number of rows, 1, and look at the actual number of rows, 490,000. Now, without changing the code or doing anything, if I just change my compatibility level to 150, and now I call this, I'm not calling this right now. Now I'm going to call the same query without any change. I thought I didn't turn on the execution, actual execution plan. And this time I also, switch the max job because it can take advantage of parallel plans executing in, yep. So right now you do not see that sort warning, right? And look at this now. Our estimates and our actual number of rows are the same, right? And what did we do here? We just changed the compatibility level from 140 to 150. So we're going to talk about interleaved execution. I'm going to just create a function here just to use it for the demo. Now I'm going to 130 like I want to behave like 2016 and turn on actual execution plan. I'm using this function right here. Again, if you see these warnings, same problem. What happened here? Estimated number of rows 100. Actual number of rows is 114,000. So the less estimate, less memory was granted, and we have a spill right now because we don't have enough to do this operation in memory. Run the same code, just going to clear it. And this time we are using compatibility level 140, means behave like 2017. Different query plan, no sort warning. Look at the function properties. Estimated number of rows, actual number of rows, same. So memory grant feedback. I'm gonna run this and then I'll show you. I'm creating a store proc just for demo purpose. Now I'm gonna run this two at the same time, but we'll be using the same query plan for both, right? Because it get called first time, get cached, and then the second one is going to use this. So let's look at the first one. See, what does it say? There's a warning. It thinks that it gave it excessive memory than it needs to, right? Because it only used 920 kilobyte, but it was allocated 67,776. But this was called first time. Even though it knows that it has excessive memory, but it did not get an adjustment because this was the first execution of this store procedure. Then come this one, same one, second execution. This time it says, I need more memory. So it shrinked because of the first one, but then it shrinked too much, right? It was granted 2200, but used 4920. And if we go to the properties now, what do we see now? See, last time we saw it's the first call, but now it is adjusting because it knows that the memory grant is not correct. So let's call this again. We do not see any warning. We go to properties, still adjusting. So it's not done yet. Call this again. At some point, and I asked this question during, I think, past summit or to Pedro, there is not a specific number that that he can give me, like after how many tries it's just going to say I'm not going to do this anymore. So as you can see here, yes, stable means, and it changed that to like to a different number. Now it knows that this is the kind of the optimal memory grant, so it's not going to adjust any longer. Scalar UDF inlining, we talked about it, so let's look at it in action. We're going to create a function. I'm checking if this function does qualify even for inlining, as I mentioned about this system view. Yes, it's inlineable equals 1. Now we turn on the actual plan. We are using this, but I also wanted to show you an example how I can disable this at a query level, right? So with this hint, I'm saying disable T Sql Scalar UDF inlining. And as usual, right, looking at this plan, you have no clue whether this function, there is a function got called. I just want to give you a tip which is not related to this talk. If you ever run a function, someone tells you that, hey, it's slow, and you need to prove them that it's due to functions, look at this property new into the management studio. It actually tells you how much time was spent on the function out of the whole query execution. So this is a good tool to know. Now I took out the hint. I'm going to call this, and you will see a widely different query plan. Now, how do I know that my function got inlined? To be sure, one is what I showed you here is not there anymore. Plus, there is a new property. Contains inline scalar T Sql UDF equals true. That's how I can say confidently, yes, my function got inlined. Batch mode on row store, we talked about it a few times. So let's take an example. Again, I'm putting the hint. I could have done this with compatibility table, but I've done it a few times. So I wanted to show you that you can also control this with the hints if you want to. And if you notice that this one, you'll feel like it's running a little bit longer because we disallow batch mode, right? So we are forcing it to use row mode, whereas we could have taken advantage of the batch mode. And once this is done, I'll run this same query without the hint, and you'll see that it will run a little bit faster. So if we go here now, as you can see here, right, it's a row mode. Now we're not changing any code, even the same values, but we just took out the hint. And I put a code here because I was using hint, but if you want to run this with a compatibility level, you should be able to see that. So it's taking advantage of the batch mode. And if you notice the timing, last time it took 24 seconds, now it's only 10 seconds. So you get more than 50% of query up to, you reduce your runtime just taking advantage of these new features, not changing your code or anything. The last one is approximate distinct count. So if I turn on my plan, I'm going to run both side by side just so I can show you one of the feature that I talked about. Especially the memory grant, if you have, this big tables and you are doing analytical work that you doesn't need the exact number of counts, use this and you'll see that your memory footprint will drastically change. Once this get ready, I can show you in the execution plan how much memory grant each of these got. And in this example, as I told you that it is a 2% with 97% probability. So this one I found that difference is about 2.6% between the exact count and the approximate count. I just wanted to mention that. That's why I put it in the in the script. And that's why Microsoft says it's with the 97%, not 100%. So if you look at here, look at the memory grant, right? 1.7 gig. And look at the memory grant here, 40 KB. But of course, what you are giving up, you are giving up, the exact count and the approximate count. And as I said, if you do this math, it's about 2.57% difference between the two. So I'm just going to go back to my slide for a minute. These are my contacts again, and we'll have, I think we have 4 minutes. So if anyone have any questions, comments they want to ask, I will answer those here.